Hello, and thank you for attending this session about securing IoT. My name is Oded Gonda, and I'm VP for Technology and Innovation in Checkpoint, dealing with research and development for IoT, among other topics. Securing IoT is in many ways easier said than done. In the age of things, we have so many types of devices that can contribute a lot to efficiency and new exciting usages. But at the same time, in security, they provide a very wide attack surface. Security is as good as the weakest link. And if an attacker is able to take hold of one of these devices or one of the control system for these devices, they can then make their way through this entire complex network and achieve a lot of potential damage. With 5G, we have even more devices that are now communicating to each other. And the traditional means of doing security through the network is becoming more and more challenging. When the device communicate with each other, or when they communicate with controllers that are very close to them, we don't have the opportunity to examine the traffic in the network, but rather if we want to achieve security, we have to do it on the device itself. This creates yet another challenge because we want to have very low latency and very small effects on these devices. If we look at IoT security today, it's a little bit like floppy diskettes, maybe 25, 30 years ago. We had a diskette, we put it into the PC, and we had no control about what's going on then. So exactly like you couldn't imagine today a network without a firewall or a PC without an antivirus, that's pretty much the situation of IoT security today. Let's see an example of what can happen because of this. This was done by Checkpoint Research and was already fixed by the relevant vendor. So this is one of many examples of what can happen when attackers can get hold of IoT devices. In the case that we saw in the video, it could be a data breach, a privacy issue, but there could also be cases where people can get control of system, can encrypt the content, and this way control traffic environments, manufacturing environments, and so on. And damages can be quite significant, as we've seen in actual cases that happened, and you probably heard about in the news. The damages for the user can be safety and health, if we are talking about power systems, water systems, elevators, and so on. It could be financial damage, and it could be reputation for those parties that are using those devices. If you're an IoT vendor, then you could also have financial damage because you might need to recall some devices. You might need to pay compensation for your users. It's a reputation damage for not making sure that the devices are secure enough. And in very extreme cases, it could be even criminal liability if there is negligence in dealing with the security aspects of the products that you provide. IoT vendors, controller vendors are well aware of these issues. They are issuing security fixes, and as we can see in the websites of many of them. However, we see a phenomena that the software is not updated. So the fact that people are having access to this software update doesn't mean that they actually go and update. And we see a situation where there could be weeks, months, even years when the device is not patched. And this is what we call a vulnerability window. That's the window where the attacker can make use of known information, known vulnerability, and attack it simply because the software was not patched yet. One of the main reasons that we see issues in IoT devices is that, like any type of software, they are using open source components. Open source components often has all kind of zero-day vulnerabilities, and this makes the device vulnerable. As we mentioned before, there is lack of built-in security mechanisms on those devices. So they are pretty much on their own in terms of their own mechanisms, and many times this is not enough. The device themselves can be accessed from the network, but they can also be accessed locally through Bluetooth or through a web portal that are used for administration, and that makes additional attack vectors. I want to tell you a little bit about the security process that we implement in Checkpoint as an example for a company that is very aware to security issues. These processes are very tight, but as you will notice, they require expertise and they are quite expensive. So it all starts with employee security orientation. Every new employee goes through security training, and then ongoing, we make sure that people are aware of security issues. They are aware of different aspects of social engineering, and for developers, how they need to develop secure code that will not be vulnerable. We put a lot of emphasis, of course, on a secured environment with all kinds of technology layers that are detecting and preventing different types of attacks in real time. This goes from mobile devices to network-based devices to PCs to cloud technologies, a very large security stack that is managed by a professional. We do ongoing risk assessments to understand where we might be more vulnerable and where we need to put more emphasis, which is a key for a good security program. We do security design review for every single new system and every single new technology, and this is done during development and before development in order to find logical issues. We validate the code for security issues, both through human examination of the code, but also through automatic tools. We do security tests and penetration tests, where we have a red team that is trying to go after a system and find whether it's vulnerable. We monitor all our dependencies, so all kinds of software components and software services that we are using as part of our solution in order to make sure that they are not vulnerable and in turn makes our solution vulnerable. And then finally, when there are security alerts, we try to handle them very, very quickly and come up with a solution. And we're very proud in being able to do it in a very short time. So all of these processes, they are very useful, but they're also very, very expensive. And that means that for the regular IoT vendor, it may be very difficult to do them. So what I like to offer are some things that may be easier for you to do. But this is not instead of doing these things. It just, if you're not able to do them to the large extent that a very security-oriented company can do. And it very much goes to risk assessment and to device hardening. Risk assessment is about knowing where you are and what are your current vulnerabilities and issues. This can be done by taking the firmware of the device, the same code package that you provide to your customers or that you are using on a device, and check it for vulnerabilities. You don't need access for the source code, but rather you scan the actual firmware and you issue a report of all kinds of potential vulnerabilities, and then you can decide whether you want to take action, whether you want to fix them immediately, whether you want to maybe change some configuration aspects, and so on. The second part, and that's actually the most important part, is having an on-device runtime protection. We call this technology a nano agent. It's a very small software agent that you can deploy on a device. And this provides preemptive protection against all kinds of vulnerabilities. And that means that even if a vulnerability is not known at the time that you issue the software, we can, in many, many cases, protect against it. But even if you come up with a software patch, but the software patch was not yet implemented by the customers, you will still be protected against a variety of different type of attack vectors. In the following video, we will see a real example of how an attacker makes use of a vulnerability in an IoT protocol called Zigbee in order to get into a lamp, a smart lamp. From the lamp, get to a controller, and from the controller, get to the network. And then we will see how this is protected by employing an agent that will block this type of attack. So once again, this was already fixed by the vendor. So as we learned here, IoT devices are no different than PCs or servers. They are running software that is developed by humans. This software can have vulnerabilities. And we need to protect those devices with security tools. The security level of IoT today is not satisfactory. There are many potential risks, as we see in the news almost every week. And security is our responsibility, and it's your responsibility as somebody that provides solution to customers. We strongly recommend to have security by design and process, as this is the most effective way to deal with security issues. But then also to do risk assessment to understand what are the issues of your products, and to have on-device IoT device security that can protect preemptively against all kinds of issues. I hope that you find this session interesting, and you're welcome to approach us if you have any questions or you want to know more about these solutions. Thank you very much.